In this video we are going to factor some perfect square trinomials. What is a perfect square trinomial? A perfect square trinomial is the square of a binomial. So we have formulas for squaring a binomial. For example, if we want to square the binomial a plus b, which means multiplying a plus b twice, or we say multiplying the binomial a plus b with itself, we get a product which is a perfect square trinomial coming from squaring a binomial. So we have two cases here. If we square a binomial where both terms are positive, we get a trinomial in all terms, positive terms. Okay? So because a square is a positive number, b, positive b squared, is a positive number, and the product of a and b and doubled is a positive product. So in other words, if in the binomial we have a plus, in the middle term of the trinomial we have also a plus. If we square a binomial when the first term is positive and the second term is negative, so what do we get? We square the first term, which is a positive, and we square the second term, negative b squared is positive. And now, when we multiply both terms, the product is negative. Positive a times negative b is negative ab, and when we double this product, we still are in a negative product, okay? So, in other words, if we have a minus in the binomial, the middle term of the trinomial will be with a negative sign. Now, since we have those formulas, when we multiply, we get this special product, which we'll call a perfect square trinomial. Okay, from multiplication, we go to addition because a trinomial is a polynomial, and in polynomial the terms are linked by addition. Now that we want to factor a perfect square trinomial, we go backwards, okay? And now we have already formulas if we want to factor a perfect square trinomial, okay? So, if we have the trinomial with a plus in the middle term, the binomial will be with a plus. But what is a binomial? What is a and b that we are looking for? Because if we find a and b, we know now we square, and these are the terms of the binomial. A and b comes from the trinomial when a is the base of the first term and b is the base of the second term. Okay? And the product of a and b is in the middle term but doubled. Okay? Now, if we have a polynomial a squared minus 2ab plus b squared, we know now how to factor as a square of the binomials with minus. Why? Because those a and b now are the basis of the first term and the last term of the trinomial, but when we multiply them, the product is negative, as we said before, and now this product is here, okay? Negative AB doubled. So, keeping this in mind, what do we need? We need the basis of the first and the last term of the trinomial, and the signs come from plus from the middle term, minus from the middle term. So this is our job. Now, if you want to use this formula, we must have a perfect square trinomial. So our job is, if it is given a trinomial, we have to recognize if it is a perfect square trinomial or not. If it is, we go and factor like this. Okay? So, again, I am looking for bases. The base from the first, the base from the second, plus from the middle term, the base from the first, the base from the second, minus because I have a minus in the middle term. And that's it. Now let's go and work on some problems. Factor the following trinomials. Example 1. x squared plus 10x plus 25. Since the coefficient of x squared is 1, I do not have a common factor. Okay, and x is not present at all, so no common factor for this trinomial. Now, I would like this to be a perfect square trinomial, okay? So, this is with a plus in the middle term, so I have the first case. So if this is a perfect square trinomial, I need only the base of the first and the second, okay? And the product of my bases doubled will satisfy the middle term. Let's check. This is very easy. X times 5, 5x, double it, 10x. Yes, this is. But let me go slowly. So what I need? I need the base of the first. I need the base of the second. This is what I need. These are things that I have to put in my trinomial, if my binomial, if this is a perfect square number. Now, I need a double product, so I have to divide 10 by 2. And 10 divided by 2 is 5, and write x. So, check. So 5x doubled, 10x, yes. Okay, so I know what is my factorization. If it is the square of a binomial with a plus, because the middle term is a plus, and now I need the basis of the first and the last, x, 5. That's it. Now let me go quickly here. T squared minus 16t plus 64, no common factors. So I need bases. 8t. These are my bases. Now the product of my bases, 8t doubled, is 16. Yes, it is. So I will write the square of the binomial with a minus. And now I will write the base t, 8. And now let me show you that I was right. So what I'm looking for? I'm looking for the base of the first, which is t. I'm looking for the base of the last, which is 8, because 8 squared is 64. So I have my basis that I need for my binomial. And now I need the double of their product, so I have to divide 16 by 2. And 16 divided by 2 is 8, and I have to write t. Yes, 8 times t is 8t. Good. Okay, now this is the product of my bases, double, you get 16 back. So, done. So, if we have a perfect square trinomial, the answer is straight away. Okay, we don't have a headache at all, because in the trinomial are our bases, okay, which will satisfy the middle term. Now, example 3. Let's check. 16, 24, 9. They are not divisible by the same number. That means no common factor. A is not present at all terms, so no common factor here. Let me go quickly and check. The base of 9 is 3, so the base of 16 is 4. And for A, it's easy. 3 times 4A, 12A, double it, 24A. So it is, okay, but let me show you. So I need the base of the first, which is 4 for 16 and A for A squared. So my first base is 4A. Now I need the base of the last, which is 3, because 3 squared is 9. Now I want that if I multiply my bases, okay, and double it, I will find the first term. So what I need here, I need a double product of bases, which is 24 divided by 2, 12a. And now check. Is this the product of my bases? Yes. 3 times 4a is 12a. Good. My factorization is a binomial squared with a plus, and the base of the first is 4a, and the base of the second is 3. Done. Let me go example 4. 4x squared minus 28xy plus 49y squared. So 4, 28, 49 are not divisible by any number. So no common factor for the coefficient. X is not present at all. Y is not present at all. No common factor. Let me go. I need now the basis. Okay? So what are the bases here? 2x. Because 2 squared is 4, x squared is x squared. Now what is the base here? 7y. Because 7 squared is 49, y squared is y squared. Okay, so what I need? I have my basis. If this is perfect square, I'm done. Now, I need the double of my product, so I have to divide 28 by 2, and 28 divided by 2 is 14xy. And I will check if this is now the product of my basis, and yes, it is. 2x times 7y is 14xy, yes. A square binomial with a minus, the first base, the second base, 2x, 7y. Done. Example 5, 162x to the third plus 144x to the second plus 32x. When I read this, I see that x is present everywhere, so I have a common factor, okay? Let me check the numbers. 162, 144, 32, all of them are divisible by 2, so I have a common factor here. And the common factor is 2 for the coefficient of x and x for the variables, okay? So open parentheses. What is left now? 162 divided by 2 is 81. From 3 x's, 1 is outside, 2 x's are left. Or dividing, we know that we subtract the exponent. 3 minus 1 is 2. Plus 144 divided by 2 is 72. From 2 x's, 1 is outside, 1 is left. Plus 32 divided by 2, 16. X is outside, close. Okay? Now I will check. May I continue factorization? And this is a trinomial. Is this a perfect square trinomial? Let me see. So, what I need here? I need the base of the first. I need the base of the last. And I need the double product of my bases. So this will come from 72, not from 144. 72 divided by 2 is 36x. Now what are my bases? This will be the product of my bases. 9x. Because 9 squared is 81, x squared is x squared. And now for the third one, for the last base, for the second base, is 4. Because 4 squared is 16. So I recognize those. They are square numbers, square variables, so I know, okay? 8x, 9x, 4. And now 9x, 4, double. Now let me check. These are my bases. 9x times 4 is 36x, yes. So, now I will continue. I have 2x, and the trinomial will be the square with a plus, and the first base is 9x, and the second is 4. Done. So I have 3 factors here. 2x is the greatest common factor, and I have a double factor here, 9x plus 4. So let's see the example 6. X squared minus 20x plus 36. The coefficient of x is 1, no common factor for the coefficient, and x is not present at all, so there is no common factor for this trinomial. Let me check. Is this a perfect square trinomial? What I need? I need the first base, which is x. I need the second base, which is 6. And now I need the product to be the half of the middle term. Okay, so I need a double product here. So 20 divided by 2 is 10x. Okay, and now I will check. 6 times x is 6x, is not 10x, so no. This is not a perfect square trinomial. Now, I could check easily here. So 6 times x is 6x, double it is 12. Okay? So here I could find that it was not. Okay? But if you write like this, after you divide the coefficient by 2, so this inside will be the product of your bases, so this is not. But it doesn't mean that this cannot be factored. We have to check, maybe we can factor this by other methods. So, since this is not a perfect square, I cannot go straight and write the square of the binomial, okay? But let me check. Let me rewrite this again. So I have x squared minus 20x plus 36. And if I can factor, I will write here x times x, because these are the factors of the first term of the trinomial. X times x is x squared. Now I need two numbers. If I find these two numbers, yes, this is factorable, okay? If I cannot find, then I say is not factorable. That's it. So what I know about those two numbers, I know that their product is the constant, because this is the form x squared plus bx plus c, which we learned before how to factor, okay? So these two numbers are the factors of 36. Multiplying those two numbers together, we get 36. And adding those two numbers together, we get the sum, negative 20. So product, negative 20 is the sum, okay? Again, the product of the numbers that I'm looking for, the sum of the numbers that I'm looking for. Now, positive 36 is a positive product, which means the numbers have the same sign. But the sum is telling us, yes, the numbers have the same sign, but they are both negative. So I know the signs of the numbers. Because negative times negative is a positive product, and negative plus a negative is a negative sum. Now, what are the factors of 36 that will satisfy 20? So 36 is 6 times 6, but 6 plus 6 is 12, okay? And I know that they are not 6 because I checked that this is not a perfect square, because if they were 6, this will be 12, okay? But let me check again. Now, what else is 36? Is 32, is 18 times 2. Okay, so 36 is 18 times 2. Both are negative. And now negative 18 plus negative 2 is negative 20. So, yes, I found two numbers, which mean, yes, I can factor. Let me place now, since the numbers have the same sign, we don't care when they write them. And that's it. We are done. So the last trinomial was not a perfect square trinomial, but this doesn't mean that it cannot be factored. So we were looking for a perfect square trinomial just to factor it easy, okay? But if it is not, we go and use another technique that we learned in the previous videos, okay? But if we cannot find those two numbers, if we try this method, we say that this is not factorable, but this trinomial is factorable, and its factors are x minus 18 times x minus 2. So this was the lesson for today, how to factor perfect square trinomials. Thank you very much that you are listening to me.